One of the most important parts of scaling up is ensuring trust in a platform. So data quality is an important part of that. And today you are with Sorakun, and Soda has been pioneering the category of data quality technology. But it's not the only aspect of data analytics that you've been doing in your career. What actually led you up to here?
It's before I was very much focused on data governance, data cataloging, and mainly data governance. And I feel that data governance and data quality goes hand in hand. One of the first conferences I went to 10 years ago was DGIQ, Data Governance and Information Quality. And for us, the DNA is really to make anything work with data, you have to work with clear business requirements. And that's what governance is all about, right? And then with data quality and how the space is evolving, we think that for the first time ever, we have a good chance of making sure that what gets set as standards on the data governance side actually can get implemented easily, and the results coming back to the data governance layer. So it's an exciting space.
And if you translate that to the software world, it looks like the data quality aspect is becoming a category by itself, with its own players, with its own methodology, with its own approach to scaling up data. It's actually more important than ever. Soda has been pioneering in that category. Do you see it the same way? Have you seen similarities, or are we drifting apart?
Absolutely. I think a couple of years ago, until a couple of years ago, people were looking for ways to catalog their data, govern it, and data quality was kind of like an afterthought. Now we see the opposite. People have so much going on. They've all built multiple pipelines. There's issues in these pipelines, and it doesn't matter what the technology is, whether you want to do advanced analytics, predictive analytics, LLMs, AI, it doesn't matter. You have to get your data correct. Regulation on the other side keeps pressing on. So having a baseline of data that's defendable that you can build on, and maybe then only catalog or govern, is a trend these days.
And getting to that baseline actually falls apart into different aspects of the data engineering workflow. On one hand, there is data testing, like the unit testing, the regression testing. That's actually testing for the known knowns. If you're into an engineering process and you start engineering based on specs, you build whatever you need to build. And at the end of your engineering process, you actually test if your deliverable matches the functional requirements. And if all is correct, your deliverable gets moved into production. But that's the point where new data starts flowing in. And engineering is out of the picture at that point, but new data is flowing in. And nobody actually has, in theory, control over what's coming in into the platform. So that needs to be tested again. And the buzzword for that seems to be data observability. Is that the area where you are working in today?
Data observability and data testing. Data observability is it's a bit of a misnomer almost, although Gartner did a really good job of clarifying with their paper. And they split it up under 5 components. You can observe the data, the actual content, and that's very powerful because rather than having to look for specific data quality issues, you can just let the algorithm observe everything and see what anomaly detection is there or what anomalies arise. Very powerful. But you can also observe the pipelines itself. You can look at the infrastructure. People look at observability for cost and where optimization and where the just anything financial. So there's a lot to it. But broadly put, when we talk about it in the pure data quality space, it's making sure that the unknowns can be found next to, and I do stress that they should be next to, testing early, testing often, and testing as left as possible. Does that make sense a bit?
It definitely makes sense. The data observability buzzword these days is a bit all over the place, and organizations are still trying to find meaning in it and a place in it in their data analytics processes. But nonetheless, it feels like super important. At least on our side, what we see is that organizations try to scale up data analytics platforms. And so these things, they start typically from a central capability point of view. A small team is pioneering something and basically setting the guidelines to grow bigger and bigger and to distribute across, say, the continent or the organization. But at that point, challenges may come in because at some point you're working in really decentralized fashion. And that's where teams have to cooperate with each other without the central capability being directly involved into engineering. It feels a bit like data mesh. Data mesh is also a big buzzword, but it becomes very tangible at some point. How do you see data quality part of that?
Yeah, whether it's data mesh or governance or any AI, any, I almost want to call it an easy button. It's still something, even with the data mesh, right? It's something that gets loaded onto the data team. Let's call it the data office team, the central team that manages the Snowflake implementation and so on. And once you take on the data, you're still responsible for it, right? So, and a mesh pushes for this, so it allows you to push the ownership left. What they say is, or what in the paradigm it says is, get a central capability for DQ and push left as possible, as far as possible, and that's really key. We really advocate for our teams that own the data quality of the new warehouse, that they test when the data is still on-prem, for example. Test it in the SQL Server or the Teradata warehouse, and if the data is not good, keep it there. And then when the data arrives, test it again. As it gets transformed, test it. As new transformations are written, test it, and then observe the warehouse as well. And then any of the other items, observing the pipelines and so on, you can all add that on top. But I think still the number one key is test early and know that, if something is wrong with the data in the originating side, who to work with. And that's where the governance comes in, of course. A data mesh is a good solution, but if you're a data mesh and the data still has made it into your world, you're still going to be stuck with a lot of the problems.
I like the analogy you made with the pushing left and basically testing as well on the source system. So we're not talking about the easy button either. You mentioned earlier as well. We really advocate for having controls in your operational system, making sure that there's decent governance, at least decent input controls. You propose to test as soon as those controls have been applied. Then you propose to move data to your data platform, test again, and then take a flow from that point on and up until the data arrives into your world within the data mesh. Is it correct?
That's correct, yeah. And as soon as you talk about data mesh or governance, the links, the integration with the governance layer, the catalogs these days, there's plenty really good catalogs that can fit different needs. That's key. That's important because that's where a lot of the context of the data lives. If there is an issue, who should we go to? The workflows, playbooks, that's all there, right? So that is, I can't stress how important that is.
Yeah. Can I challenge you a bit on that, Koen? Up until now, it all feels like a very technical process. And well, I know the process from a technical point of view for a few years now. It's always been the playing ground of engineers and people who have technical affinity to define these tests and these controls and make sure that data gets validated before it ends up in teams. But it's also a constraint. Like there's an endless amount of tests that can be applied to data, but there's not this endless amount of data engineers who come up with these scripts or tactics to test for those data quality roles. How do you see this evolving?
Yeah, good point, good question. We see a huge push for these data engineers that have a wider range, a range of tools to be able to work with non-technical business users, and that's really where the innovation lies. You're only going to get stuck if you're writing script or something very technical that the business really can't work with. You need to be able to marry IT and business together, and to alleviate the data engineers, you need to be able to get requirements from the business, and when it gets implemented, wherever it is in that flow that we just discussed, the results need to flow back to the business. I'll give you an example. If I'm going into a boardroom and I've got a report and my catalog says certified or it's valid, fantastic. But if an hour ago pipelines ran and the data is off, I need to see that right away, right? I need to know that my report can't be trusted, and I can use Lineage to find out all of that, but that actionable data governance. And to get there, it's kind of like the first time ever I see that this is possible because of the LLMs and the AI machine learning. Because what that allows us to do is, I'll just picture a scenario, but a data steward coming into a catalog saying like, oh, this report, we had complaints about it, and the data was off. I went into the board meeting, but the data was off. From now on, I want the machine or our setup to test when our feeds come in from Bloomberg or whatever, Moody's or whatever scenario we're in. I want all the data to be fresh. I want these valid values. All these standards get put in place, and they can write it in English. 10 years ago, when I was implementing data governance, we laughed and dreamed about how nice it would be to have this. But now, somebody can actually type it in English, and it gets automatically translated to the data quality rules, the observability rule, and that goes into the system. We still advocate for it coming as an inbox ticket to a data engineer so that they can, back to Gartner's point, make sure that the cost is optimized and so on, especially on certain systems, you can quickly rake up a lot of costs. But that it gets plugged in as left as possible, maybe also when the code gets changed and so on, but it gets implemented. And then the link to the catalog, when it runs, it filters back and it gets the data back to the catalog. That's possible now, and that's exciting stuff.
All right, so let me try to reframe it a little bit. And we were talking about engineering capabilities first, and now we stepped into the world of LLMs and these large language models that are super popular these days. Does it mean that like engineers are no longer the bottleneck when it comes down to analyzing data quality rules, but that that part of the work can actually be outsourced to business people who can write whatever they need in plain English?
Yeah, that is the demand of the market. If there is one demand I hear from customers, it's like, hey, we don't want to be the bottleneck, but we also don't want to be the intake for all data problems. We want self-serve, whatever you want to call it, no code, machine learning, an easy button, but they want the business to be able to set their standards when they're working in Salesforce, for example, and say like, hey, these fields, we only work in these currencies, and that comes back to the data engineer who implemented, or even better, if it's a simple rule, it's just implemented right away, of course.
Yeah, I get the value of that when we are actually checking for specific relationships that might be super complex in the business world. So those are the things that are typically a little bit harder to translate into some wording that an engineer is comfortable with. But the LLM should then actually, in theory or in practice, be able to define those relationships for the engineer, right?
That's correct. And so Soda's launched one of those LLMs, a model that we trained ourselves. The results are very impressive. Of course, we need to add more, right? Test more and have test on bigger data sets. But these LLMs are really good at learning the rules and test suites. So it's really, really impressive to see.
Are they trained on like generic data sets, or can we fine tune the LLM that you are proposing based on our own internal data?
At the moment, it's Soda's model that we're training because it's focused, also with security requirements in thinking of those. It's not related to ChatGPT, for example. It's purely an LLM that can only spit out Soda CL, which is human readable, human writable. That's what we're focusing on first, and understanding all the different dialects. For example, releasing reconciliation rules. It should do that as well. And then we can move into like, hey, can we give this to customers so they can train on their data? But that's not the case yet.
Yeah. So in that case, you are moving closer and closer to the business user still again. But the data engineer is not cut out of the equation, right? They are still on the processing end. They get instructions from an LLM this time, but not from a business user directly if it's a bit more of a complex rule. But the engineer still does the implementation, right?
Absolutely, yeah. We build for the modern data stack. Whoever is building data pipelines with a DBT, Airflow, Fivetran, that's our world. But we want to help those people. And we've been on the other side, like we want to marry the two together. It's more about helping data engineers getting the job done, really, and making sure they don't have to wake up at 6 a.m. to look at a pipeline issue or bad data.
And that's not a theoretical situation. I think we all have seen those situations or even have been part of that in our past. And like nobody wants to be in that situation again. And if technology can help us out on that, why not? Huh? Yeah. So you said modern data stack, and the modern data stack is this composition of all of these different services that all together become a data platform. We are working with Snowflake mainly. The way I understood Soda is that it is actually like behaving like a layer on top of Snowflake, whereas Soda basically uses the data stored in Snowflake and applies tests by just translating the Soda CL into SQL commands. Is that right?
Yeah, that's correct. And like we've discussed before, we want to, of course, prevent bad data making it to Snowflake. So ideally, we circuit break in the pipeline where when the data is being loaded, but then still, you should still observe what's happening in Snowflake. And then that's exactly what you say. So the compute happens in Snowflake. We don't move any data. That wouldn't be a good idea. It happens in a very performant way in Snowflake.
Yeah, and now you said the compute happens in Snowflake as well, and actually I find it a very important aspect of working with Soda. The fact that the data does not leave Snowflake itself means that all of the data and all of the processing is governed by the master service agreements that have been negotiated with Snowflake. So in terms of working with large organizations, there's a few checkboxes that are already pre-checked that have to do with data localization, compliance, reporting, that sort of thing. Huh?
Yeah, an important point. And also just the speed, of course. It is a very performant data warehouse, as you well know. So if you do it in the right way, you can do it very, very effectively.
Yeah, and just like another aspect I really like about working with Soda, and that's the build or buy argument. Many of those modern data stack teams, they typically start off with open source because in organizations, it's easier to start pioneering with open source and try to find out what capability you need at what point in time. And Soda also has this Soda core component, and that is very easy to start working with on top of Snowflake, but in an open source version. How do you see growth from there?
Yeah, open source is our DNA. We're sticking to that. That is, it's been great for Soda. We have a thriving community. People contribute things. It's also fantastic to always be able to say, "Hey, we're thinking of this. How do you see this?" Or "Who wants to test this?" We are obviously, like most open source companies, also building a commercial product. But a lot of what customers give as feedback goes in there, right? And that's then more things visual. We're working on and completely self-serve UX experience, contribution workflows with the catalogs, catalog integrations, and of course a lot of things like dashboarding and so on. But the core of the product, Soda CL, the human readable, human writable language, will always be open source.
So if I'm not entirely sure if I can trust Soda as a company, I can basically inspect the source code of the open source component. Then I will see that Soda does not, the open source component does not move data out of Snowflake, but just summarizes metric definitions. And the SaaS component, your commercial offering, is only doing the analysis and the reporting on top of those metrics, right?
Yeah, that's correct. That is absolutely right.
Also, another important aspect, of course, from in scaling up. So, if your data analytics team becomes too popular and there's way too many projects going on for your capacity, it's really important to choose wisely what sort of work you do as a team or what sort of work you outsource. And maintaining dashboarding and analytics on top of data quality actually should not be part of the job of data engineer. It is basically reliability. It is just making sure there's uptime for the platform and also guaranteeing access to business stakeholders who typically do not have anything to do with data engineering directly. How do you look at that?
Yeah, I second what you said. Often, when we show what could be given out of the box with commercial, it often is a no-brainer to then say like, okay, let us stop doing that. Data engineers already have a lot of work. It's very easy to say, look, focus on what's value adding for you, the products that you're building. Don't start building too much on, for example, dashboarding around data quality when you can get that right. That's and it's kind of like a maturity flow. Data engineers like to build an open source stack, and it's easy because the modern data stack works with each other. 100% valid to start with that, but I do agree. Once you're growing, look for things that can help and speed up and make it easier rather than build more yourself.
Yeah, love the way you approach this. It's definitely the maturity curve we see as well in organizations. Huh? So when the team is pioneering, everything works in open source. But as soon as the projects become a bit bigger, people need to focus. They scale out, and that's where like a commercial offering of a product like Soda comes into play. Another interesting aspect that I really like about the way you guys are designing Soda is the fact that you want to be a valid player of the open ecosystem that the modern data stack is. Now, I've seen you guys integrate with catalogs, with Snowflake, with even competing data platforms. What's the strategy there?
It's very simple. When a data engineer needs something in their toolbox, we want Soda to be there. We just released our GitHub action on the marketplace as well. That's just another part of that. I will do it for Airflow as well. It needs to just be something, we see it literally as something that you take off the shelf. I need it on-prem, I install my agent and it runs. I need it in my Airflow, I plug it in. After DBT, plug it in and it reads the DBT results. Plug it on Snowflake. So that stack, it's what guides us, right? We know if you have 100 customers doing it on Snowflake, you know that that's where you have to look. Same with Git. People want to be able to, whenever they transform something or change new transformation code, they want to be able to have that as part of their test suite. So it's kind of like what guides us, and it just works well, right, to be part of that modern data stack.
Yeah. How do you see the future from here? Do you guys like want to build your own data catalog, or will you become just more specialized and integrate with the broad data cataloging landscape?
We're onto something with marrying IT and business. It's our DNA, our background, so that's going to be full steam ahead. More integrations with catalogs, also bi-directional. We will only be happy when in full production, people that have no idea of any code or even tables and columns, that they can just contribute to data quality and see the results back within, I don't know, within the day, let's say. And that it's actionable, right? It tells them their data products are good, where there's issues, where there's potential issues, and then the full dashboarding on top of that. So it's 100% data engineer with business working together through Soda. That would be nice.
Soda. Yeah, that would be nice, huh? In an ideal scenario, who would like take the lead in a data quality improvement program? I assume you come in some place where there's no data quality initiative launched yet. Would you assume business to be spearheading, or would you assume that IT takes the lead in there?
It depends a bit on what the nature of the business is. If there's anything regulatory, the business will have clear requirements and they know exactly what to test for. And it's typically testing and not observability. Same if it's data products. If you're selling products that largely depend on data, you know that you're not going to build them and release them and then wait for an alert to come up. You will test upfront. So with those customers, they have very, very clear requirements coming in. But we also get a lot of data engineering managers that, they come in, there's so much to do. Every data issue seems to be a new one and they just need help. And for that, it's probably better to just say, like, let's get a baseline first. What are your tools? Let's observe it, maybe in some initial testing, and then have a dashboard, and then see where should we step in. Those people need help, basically.
Yeah. When you explain it like this, I would assume that your ideal entry point in a technical environment would be like the central capability for, say, a data mesh. It's not a better move to start in a decentralized capability as somebody's own world, but like, let's make sure that Soda is part of the all-encompassing platform where Snowflake also exists, where DBT often exists as well, right?
Yeah, that's fair to say. Of course, we come in often the other way as well, especially via open source. But also, if I think of like the most RFPs we get in, it almost specifically says we want to stop doing this scattered approach and get to a centralized capability. It doesn't always talk about data mesh, but definitely centralized capability around DQ that we can plug in everywhere. That is a key thing that the market seems to ask for.
Yeah, and if they actually want to start like today by using Soda, what do they do? Go to the open source website, click the install button. What's an ideal spot there?
So Soda is very transparent. Our documentation is online. Anyone can start. You go to the website, you start a trial. It's 45 days, which means you can do at least one or two end-to-end capabilities, and you just get going. And within within a day you'll be up and running. That's our ethos, right? Coming from open source, so it's there for everybody to try.
Yeah. Um, if I hadn't tried it earlier on and then years ago even, I would say I'm jumping to the website and I will start trying it out today. But I know the product, so all I have left to do is to thank you for the conversation. It was really interesting to learn about how you see LLMs as being part of the data quality process. Also, how you see scaling up using open source, going to the SaaS offering, and also about decentralizing the capability of defining the data quality rules. Huh? So I'd love to talk with you more about that, but it will be for some other session.
Sounds good to me. Thanks for having me, Joris. Really good conversation. Thank you.